Connect, collaborate, discover. Transforming research and education networks to the power of N. I'm Kate Winn, Head of Executive Communications for the Network Infrastructure Group at Nokia. And this is Reconnect, where we dive into today's finest research and education networks in the company of some of the great minds behind them. Today, we're looking at CERF, a collaborative organisation for IT in Dutch education and research. Recently, CERF and Nokia successfully trialled an 800 GE transmission over a 1,649-kilometre existing fibre link, connecting research facilities at NIKEV and CERN. This expanded capacity holds out exciting prospects for existing infrastructures, which will soon be able to handle some of the largest data exchanges in the world and enables a massive upgrade to CERN's Large Hadron Collider. I'm joined today by CERF's Karin Wessel, who is Product and Engagement Manager for International Network Services, in which role she promotes CERF's research and education network infrastructure and services. My second guest, Edoardo Martelli, is a senior network engineer at CERN and is part of CERN's Quantum Technology Initiative, a comprehensive R&D and academic collaboration program covering different needs across CERN and the high-energy physics community. We're also joined by Dennis de Boer, who is the Senior Account Manager for Public Safety at Nokia's Network Infrastructure Group, into whose responsibility area this project falls. Thank you so much for joining us. I'd like to start with you, Karin, if I may. Please tell us a little bit about CERF and specifically about your role there.
So CERF is an NREN, the Dutch National Research and Educational Network. It is an association. It is governed by its members, and they are research institutes and higher education institutes. And also the academic hospitals are a part of that. And CERF, together with the members, we provide the best possible digital infrastructure for their needs in both education and science. We are expecting a big increase in data from the LHC CERN project, but also from other similar data-intensive research projects such as SKA and LOFAR astronomy projects, and maybe the Einstein telescope and some other research projects. And so we need to plan ahead and make sure that the network will be able to deal with that increasing demand.
Edoardo, I'm sure you have some comments on that.
So High-Luminosity LHC is a next upgrade of the accelerator. High-luminosity means that we will be able to concentrate more particles in this that will run in the accelerator, increasing the number of collisions that will happen every second. So it's like you have many mosquitoes flying together, and they in two directions. And the more mosquitoes you put together, the more chances they will have, two crashes together.
Excellent, excellent. Yes, the more mosquitoes we can take out of the equation, the better. So I'm all in favour of that.
Yeah, so every of this collision is like a picture, in a 3D picture. And with the high luminosity, we will increase this number of collisions per second for 100 times. So it will be 100 times more data than what we have today. Today we are exporting around 500-600 gigabit per second. So that will be increased to 6 terabits. Yeah, 6, probably 6.
Okay. I wanted to ask as well about what is the role of CERN in testing data transmission over CERF's optical network? How does that work?
For CERN, the test was very important because we are upgrading our accelerator and we will produce more data, and we need to transmit this data out of CERN. So in Amsterdam, we have NIKEV, that is one of our main collaborators, and so they need to receive the biggest amount of data as possible, and using these very high-speed links will help our mission. Yep. So CERF took care of setting up the transmission and the connection, and then we connected this link to CERN in Geneva and to NICEF in Amsterdam. NICEF is one of our main collaborators for this research. It's a physics institute, and they have a big computer center. So then we transferred real data that we collect from the accelerator from CERN to NICEF using this link, and we achieved more than 600 gigabit per second. So it was a very good performance. The limit was a number of our storage services that were not able to push more than that.
Dennis, tell us a little bit about how Nokia was involved in the project. For example, could you tell us about what Nokia optical technologies were used in the tests?
So I was requested last year by CERF if Nokia was interested to be part of this trial, mainly because also Nokia has now the 8030 optical systems available, which can do 800 gig transmission over optical lines. So that would actually give the advantage, looking toward the amount of data which will come later on from the CERN Center, to see are we capable over the existing 1643 kilometer glass fiber line to transmit this high data. So, of course, for us it was very interesting as Nokia, as we are also focusing very much on the segment research and education. And therefore we stepped in, and I think the overall project was around, I say, maybe 10 months in total, from the first calls, doing project meetings during the weeks. One thing to mention also, and the outcome of this whole pilot, was actually that this glass fiber connection is 12 years old, as I understood. And interesting to see that currently, with the current innovations we have done as Nokia, but also the standard industry, we are capable to actually reuse these kind of long-lasting connections to the highest standard bandwidth. I think it was originally planned to do 100 gig, 200 gig over that link when it was built, and that you currently can deploy 800 gig over the same link. So there's no need already to put new fiber into the ground. You can use with the latest technology existing fiber. So from a sustainability point of view, I think it's a very good point. It costs quite a lot to put fiber into the ground. So it also is a showing towards the market, not only education and research, but also CSPs or other markets, that the current technology increase of bandwidth can be reused.
Karin and Edoardo, back to you. What are the next steps for CERF to support the HL-LHC project and to prepare the network for it?
Yes, at CERF we are currently procuring a broker. We are going to upgrade and update our network, and we should finalize that process, if I'm not mistaken, in October. And we are looking for a multi-vendor approach, which is why we are procuring a broker instead of doing a proper procurement for a new vendor, so that we can then have a multi-vendor network. And that's also why this test with Nokia was interesting, because it also proved the interoperability of the super coherent optics, or what they are called, in our network. And yes, so we are also constantly in touch with CERN to discuss upgrades and improvements to our collaboration.
We have been a very long collaboration with CERF. We tested the first 100 gig, then multiple 100 gig, 400 gig, 800 gig. So we are looking forward for the next step. That will be probably 1.6 terabit per second. So
Okay, fantastic. I'm afraid that's all we've got time for. I'd like to thank all of our guests, Karin Wessel, Edoardo Martelli, and Dennis de Boer. I'm Kate Winn, and thank you for listening. It's always amazing to see how customers are using networks to unlock new research and discoveries. If you'd like to learn more about the RENs we've discussed and the technologies behind them, visit our website.